Hello, my name is Mark Crawford. This is my data mining exercise assignment. For this assignment, I'll be using Kaggle.com. I've found a gender recognition by voice dataset that I'll be going over. I've put the link here. So let's go ahead and start with the first key point. So my first key point is that clustering reduces the size of dataset required that requires processing by finding similar items and assigning them to a cluster. So why is this important? It reduces the build time of neural networks and trees, and it can also reduce the recommendation time of memory-based reasoning and naive Bayes models. So I put the simple image here that I've pulled from SASMiner that shows that a simple cluster or a simple cluster creation with 3 different clusters. And visually you can see, the circles being the same size. If you had to recommend, say, for cluster 1 versus for cluster 2, your time for cluster 1 is going to be higher. Whereas if you're recommending for cluster 3 versus cluster 1, your recommendation time is going to be lower for cluster 3. So I'll go ahead and I'll also show just the basics here of what I've set up. So I've imported the file, partitioned the data into training, validation sets. I've set up the cluster here, and then I had it produce a segment profile along with Graph Explorer. So next we'll go into the second key point, which is how is clustering done. So items are clustered based on each individual attribute. So to understand this visually, SASMiner provides a segment profile to graphically show exactly how each cluster was created. And this gives us a chart and readout of data here. So I've put this image here. So we can see here we have the 3 clusters, which I was showing above. So we've got these 3 clusters that have been created. And they're referred to as segments, so we have segment 1, segment 2, and segment 3. Now, seeing as segment 3 had far less records in it for the cluster, as you can see the cluster size is a lot smaller. You can see the data appears to be fairly sparse. Whereas, so we're going to focus on segment 1 and segment 2, or cluster 1 and cluster 2. And you can see that in segment 1 here, we've got the mean frequency of the voice. So the mean frequency of the voice for segment 1 tends to shift to the right here, whereas this mean frequency is shifted to the left here. So we can see that this is a key differentiating point in the cluster. I'll move on to key point number 3. Key point is in data mining is always best to use multiple models to explore the data. So this will give you really the best well-rounded understanding of the data itself, where it's coming from, what it's doing, and how it's interacting with each variable. So I have, as you can see, as I showed in Data Miner, I've created the decision tree, memory-based reasoning, and an auto-neural, which is a neural net. And we've run the model given this voice recognition data. And for memory-based reasoning, for the decision tree, and for the neural network, and gotten the misclassification rate, which tells us overall how accurate the model is. And so you can see the memory-based reasoning gave a 0.27, which is the highest misclassification rate, meaning that it misclassified the most records, therefore it's the least accurate. Next we go down to the decision tree, which gave us a 0.02, or 2%. So this was substantially more accurate in terms of how many records were misclassified. Then we go down to the neural network, and we can see here that it was substantially better than both, and it gave us 0.0047. Now this is a little bit misleading because when we take a look at all of these, I'm just showing this for the training data set and showing just this one run here. So that brings me to the next key point, which is an overfitting a model. This is very common in neural networks. So even though you can see we had a very good classification or misclassification rate here. When we went on to the next set of data to basically apply the model, we take a look and we actually got a score that's worse off than our decision tree. And the reason is that we have overfit the model specifically for the data that was provided. And then when we try different records, it's actually causing the model to be less accurate. So, getting the most accurate model isn't always going to be the best when you attempt to apply it to different types of data. And my last key point is that the efficiency of a model is crucial when you're determining how to use it. So when you take a look at tree models, it takes a medium amount of time to build them. However, they run extremely quickly once they're built, and they're fairly accurate. Neural networks, the model takes a large amount of time to build, substantially longer, but they can also be run extremely fast once built, and they are very, very accurate. They're the most accurate. So and the next we have is the nearest neighbor models, which the model takes a small amount of time to build. It runs somewhat slow once it's built, but it is fairly accurate. So really, between these three models, we have a trade-off between build time, runtime, and accuracy. And that needs to be taken into consideration when you're considering, say, developing an application. Do you need the model to be built multiple times? If so, multiple times in real time, the nearest neighbor may be your best option. Whereas if you can build the model once and then apply it to every single new record that comes in, a tree or a neural network is going to serve you better. Thank you for your time.